Okay, so I'm going to try working this one out while recording it so I can upload the video of me working it out, and it'll go on Canvas as well, in particular for my White Day class. Okay, here we go. Now, I'm going to do the quotient rule. So, quotient rule says the derivative is low, derivative high. So let's take the derivative of the top. So let's see if we got this now. Think of this. This is a parenthesis squared, so it becomes 2 times the parenthesis raised to the 2 minus 1, which would be 1 times, now what's the derivative of inside the parenthesis? That would be times 3. So that's the derivative of high times the low. So then I'm going to write times the low, 2x minus 1 cubed. So that's low d high. Is everybody comfortable with low d high? Minus high, I'm going to go ahead and write it, 3x minus 2 squared d low. So we need to take the derivative of our denominator. So let's go. Let's think parentheses cubed. What's the derivative of something cubed? It would be 3. That's something, which is 2x minus 1. Now raised to the second, 3 minus 1, times, what's the derivative of 2x minus 1? Times 2. Times 2. There, we'll do that. Now, this is all over 2x minus 1 cubed squared. So how about 2x minus 1 raised to the 6th? Everybody okay with what just happened there? Ask questions. What was that? Cubed? Yeah. Okay. Now, in our numerator, let's factor out the GCF. This is necessary. I'm going to have one of these on your quiz on Tuesday where you're going to have to factor out the GCF. So let's look in the numerator. Okay? All right. So they both have looks like a 2 times 3. They both have a 6. Is that correct? So they both have a 6. Let's factor out the 6. They both have a 3x minus 2. They have one of them. So we're going to take out the 3x minus 2. Everybody agree? They both have a 2x minus 1. How many 2x minus 1s can I take out? 2. So 2x minus 1 squared. And then do brackets. What's left over? On the first part, what's left over? So when I say first part, follow my cursor here. This entire term right here. What's left over? Just a 2x minus 1 raised to the 1 power. So I'll write 2x minus 1. Agree? Minus, I have what left over here? Just a 3x minus 2. Look what I'm going to do though, guys. When I take minus the 3x minus 2, it's minus 3x plus 2, because I distributed the negative through. Does everybody agree with that? Over still the 2x minus 1 raised to the 6. See how things are going to work out really clean here. Okay, let's do another step of simplifying. So now I have y prime equals, okay, look inside this bracket. What's this bracket become? It becomes negative x plus 1. Okay? You can leave it like that. Sometimes your textbook's factoring out a negative, and they put a negative in front, and then they make this x minus 1. Have you guys noticed that? I'm okay if you don't, but if you did, that's fine. But what can I do? I can cancel out what? I can cancel out 2x minus 1. So I'm left with this. I'm left with 6 times 3x minus 2 times negative x plus 1 all over 2x minus 1 raised to the 4th. How was that? Okay, let me hit pause on my video here. So I'm going to jump in on this one. So derivative of the first would be 4 times the quantity 7x squared minus 3, now raised to the 3rd power, times, what's the derivative of 7x squared? 14x, times the second term, which is 5x minus 2 quantity cubed. Everybody agree with that? Plus derivative of the second term times the first. So I'm going to write the first term, which was 7x squared minus 3 raised to the 4th times, here we go, 3 times 5x minus 2 raised to the 2nd times 5. Does that look right? Okay, let's simplify it by factoring out. Okay, I have this term plus this term. Let's see, what do they both have in them? Let's see here. They both have a 7x squared minus 3 cubed. So we take that out, the 7x squared minus 3 cubed. They both have in them 5x minus 2 squared. And what's remaining? Here we go. I guess what's remaining is a 4 times 14x, which would be, let's see here, 6, 4, is that 50, is that 56x? So 56x times, what else? 5x minus 2 plus 15 times a 7x squared minus 3. Does that look right? Okay, I bet I can simplify in that bracket. So 56 times 5 would be 280 x squared. Does that sound right? Help me out here. Hold me accountable. It's 56 times 5. I'm trying to do that in my head. 280 x squared. I'm going to write it right below it. 280 x squared minus 112x plus 15 times 7, see, 30, 60, 90. Is that 105x squared? Minus 45. Yeah, see, look. See how that I can combine like terms here? So now I'm left with 280 plus 105 would be 385 x squared minus 112x minus 45 times the first two terms, which are 7x squared minus 3 quantity cubed and 5x minus 2 quantity squared. There's my answer. So that is the derivative using the product rule, and then within the product rule, the chain rule. So y prime of 1, let's see here, you guys, I'll let you help me out here. 7 minus 3 is 4. 4 cubed would be what? 64 times 5 minus 2 is 3. 3 squared is 9 times 385 minus 112 minus 45. Is that 228? Anybody else get that? And then when you multiply those three together, I have the answer. It's 131,328. Does that sound right? So, look up here. What's the derivative of sine of 3x, cosine 3x, and then what's the derivative of 3x? 3. I just put it in front. So that's f prime of x there. Okay? Number 2, if I'm going to find g prime of x, here we go. What's the derivative of something cubed? 3 times that something, which was sine of 3x, now squared. Agree? And didn't we just find the derivative of sine? Then I have to take the derivative of what's inside. What's the derivative of sine of 3x? We just found it right here. It's what? 3 cosine 3x. So times 3 cosine 3x. What would I do to simplify that a little bit? I would take what? The 3 times the 3 and put 9. Sine of 3x squared cosine of 3x. Would everybody agree with that? Okay, now look at h of x. I'll let you all get this. Everybody get this. Everybody up to here with me? Okay, what's h prime of x? Hey, didn't I just find this derivative? It's that. So h prime of x would be this. I'm going to write it again. 9 sine of 3x squared cosine 3x plus, guys, what's the derivative of 5x? Plus 5. Okay, now look at number 4. I may run out of room in number 4. Look at number 4. We have the derivative of all this right here. But I first have to start with 2 times this raised to the 1 times this. You follow me? So it's going to become, if you want to watch me here, it's going to become 2 times all this. So 2 times sine of 3x quantity cubed plus 5x raised to the first power now. Everybody agree? And then look up here, please. The derivative of everything inside which you just found in the problem above. So times, I'm going to put parentheses, that whole thing. And I got to have parentheses because it's 9 sine of 3x quantity squared cosine 3x, and because of the plus 5, I had to put brackets, or I'll put a bracket here, showing that it's this times all this. So that's why the bracket was necessary, because it was the derivative of everything inside. Okay. You guys all have that written down? Because I'll have to slide my paper down. Well, the first thing I do is I would rewrite that k of x as x plus x raised to a negative 1. Would you agree with that? So therefore, k prime, helps if I could write k. K prime of x would be 1 minus x raised to a negative 2. Is everybody comfortable with that? Okay. Now look up here. Now this, how should you rewrite L of x? Let's rewrite it as parentheses x plus, I'm going to leave it 1 over x because I already know what the derivative of that is. But now it's raised to a 1/2. Everybody agree? So L prime x would be, chain rule, here we go, 1/2 times x plus 1 over x, now raised to the what, guys? Negative 1/2. Then make a bracket times, look up here please, let's make sure we're all clear, the derivative of everything inside, which we just did right here. So, hey, I'm going to rewrite this now as 1 minus, how could I rewrite x raised to negative 2 more cleanly? 1 over x squared. I'm okay with you leaving it just like that, okay, people? I'm okay with that. Now, son of a buck, look at number 7. I have this, which I just found, times, didn't we just derive on number 4? Was that this? Okay, so product rule. Woo! So m prime of x equals, okay, the derivative of the first term, which is this guy. Everybody agree with that? So I'm going to write 1/2 times the quantity of x plus 1 over x raised to a negative 1/2 times 1 minus 1 over x squared times the second guy, which is all that, sine of 3x cubed plus 5x raised to the second, plus first function, I'm going to write it originally, square root of x plus 1 over x times the derivative of the second, which you have on your paper before this problem. I don't have it anymore. Mine went away. Do you have it? It's that long thing, right? It's the long thing for number 4, isn't it? The whole thing? Is it this? I'm going off. Ms. Ruff, can I trust yours? Yes or no? Can I trust yours?
Yeah.
Okay, good. I trust it. I saw you hesitate for a second. So sine of 3x cubed plus 5x times 9 sine, I don't like how you have your parentheses. I don't know what's squared. Okay, 3x, this is what's squared, the sine of 3x, and then, I'm running out of room, cosine 3x, and then is it a plus 5? I made it. That's okay. I want the derivative of 2 times f of x at x equals 2. Well, first of all, what's the derivative? Excuse me. What's the derivative of 2f of x? It would be 2 f prime of x. Everybody okay with that? Which would then equal 2 times f prime of 2, because I'm finding it at x equals 2. Here we go. Here's x equals 2. What's f prime of 2? 1/3. So it'd be 2 times 1/3. I'm going to write it all out, which obviously gives me 2/3. See how I did that? Okay. So that would be f prime of x times g of x plus, you could write it as f of x times g prime of x, or you could have wrote it the other way, g prime of x times f of x. And now you're going to find at 3. So you're going to find f prime of 3. Here, I'm just going to write it. What is what is f prime of 3, 2 pi times g of 3, which is negative 4, plus, I'm running out of room here, plus f of 3 be 3 times g prime of 3, which would be 5. So probably we should write it as negative 8 pi plus 3 times 5 is plus 15. Did you all get to there? You okay with that one? Okay, I'm going to hit rule would be, what's the derivative of f of g of x? F prime of g of x times what, guys? The derivative of g of x, so g prime of x. This is huge. Can you all follow me with this being the chain rule? I take the derivative of f, everything inside, times the derivative of what's inside. So now I can find f prime of 2. Be careful here. It would be f prime, look, of g of 2 times g prime of 2. So when we go to the table, I need to look up here. I need to find g of 2. G of 2 is 2. So g of 2 is 2. Then I find f prime of 2. F prime of 2 is 1/3 times what? G prime of 2, which is negative 3, which equals negative 1. Everybody okay with how we did that one? Okay, I'm going to erase it. So here we go. I'm going to erase it. Boom, gone. All right, back to it. Let's do f together. That should be rewritten as, before we take the derivative, f of x raised to the 1/2. This should be no problem. Here we go. Let's take the derivative of that. The derivative of that would be, here I'm going to erase that right there. That's how it should be. It's f of x raised to 1/2. The derivative of that would be 1/2 f of x raised to a negative 1/2 times what, guys? F prime x. Then you plug in the 2. So I'm finding f of 2. F of 2's 8. See it? So it's 1/2 times, well, let's think about this. If f of 2 is 8, that's 8 raised to negative 1/2. Isn't that the same thing as 1 over the square root of 8? Times the derivative of f at 2, which is 1/3. Kind of ugly, but I'll get the answer, because 1/2 times 1/3 is 1/6. And isn't square root of 8 2 square root of 2? So 6 times 2, 1 over 12 square root 2. I think. Hold me accountable. Am I right on that? 4, 2, 4. Yeah. You don't have to rationalize the denominator and multiply both top and bottom by the square root of 2. What do you guys think? So the derivative at, let's see that, so if I have g of x raised to a negative 1, that would be, the derivative would be negative g of x raised to a negative 2. Oh, shoot. I erased it. Maybe I can go back. There we go. Raised to a negative 2. Everybody agree with that? Am I forgetting anything? Times what? G prime of x. From here,
This would become negative. I'm going to do 1 over g of x raised to the positive 2 with the g prime of x in the numerator.
And then I'm finding it for what value? Finding it for 3. Oh shoot, I can't see my table. You okay? I don't know if I look over your shoulder here. So g prime of 3 would be 5, so negative 5 over g of 3 is negative 4, and negative 4 squared is 16. Anybody else get that? Okay, they're telling us h is, what's another way to write that? Is that f of x times g of x? No, that's what? How should I write that? F of g of x. Everybody agree with that? Okay, so let's just go ahead and write this now. What would h prime x be? What would h prime of x be? It would be f prime of g of x times what, guys? G prime x. Cool. Okay? I'm asking you to find h at 1. Here we go. Let's find f prime of g of 1. I'm going to write that. F prime of g of 1. Here's g. This is g. What's the value at g of 1? 3. So we're going to find f prime of 3 times g prime of 3. How the heck do you... I only gave you the f and g function. What is f prime of 3? So where's f at? Where's f at? Right here's f. Here's 3. Oh, okay. Huh? We're finding both, aren't we? We're going to find f prime of 3 times g prime of 3. Am I agree? Let's do g prime. Everybody look right here. Let's do this one first, Miss Horde, because it's the easier one. Everybody follow me on the graph of g. Here's 3. Am I right? Oh, crap. I'm sorry, guys. That's what you were saying, weren't you? This needs to be what? G prime of 1. I'm sorry. Because g of 1 is 3, and I got off. Okay. Thank you. Okay, ready? Let's find g prime of 1 first. Here's g. Everybody agree this is g? Here's 1. What's the derivative at g of 1? The derivative is the slope of the tangent line. What's the slope of this straight line? It's going up. Is it going up 3 over 1? Okay, so right here, what's g prime of 1? 3. Now f prime of 3, come over here. There's 3. Here's f. What's the slope of this line? Because that's the derivative.
That's G.
Oh, that's g. Crap, where's g? Here's... I'm getting off. Here's f. Follow f. Here's 3. Ooh, it's the slope here. Okay, it's on a curve, isn't it? Okay, so we got to kind of... I'm going to draw it. I'm going to draw on it a little bit. Here's f at 3. I don't know. That looks like a slope of 1 to me. What do you guys think? Want to estimate slope of 1? I like that. So we're going to call that 1. That's an estimation. 1 times 3 is 3. Okay? Hello. Quick. It's okay. Are you all to here on number 2? Are you all to here? Is it f prime of 0 times g prime of 0? Did I get that right? Okay, let's see if I can do it right this time. Here's f. So the slope at 0 is a negative value, agree? Negative, I'm just going to make it -1 again, even though it might not be exact, it's -1. And then the slope at G of 0, that slope we already found is what, guys? 3. So we'll go 1 times 3, so that equals 3. Again, the slope at f of 0 is a negative. Oh, I didn't put negative, did I? -1. So therefore, -3. It's hard to do all this on the iPad. I'm trying to record it, but I'm okay. Y'all good?
Yeah.
No worries. I mean, maybe Emma might hate you for life. Like she's been looking forward to drinking that Powerade all day. Okay. All right, and then the last one asks, I'm gonna take this one away. The last one asks, does h prime of 2 exist? And go ahead and tell me yes or no. What do you have to take? Well, you guys work it through. I think it does exist.